So let's go to our first question on relative velocity. So I explained all the concept on relative velocity. Even this question they will ask you. Yes. Now they have asked us in form of, I can say in form of a river. Yes. So now when you look at this question there says the Kafue River in Kitwe runs from north to south. A student intends to cross to the other side of Kafue from Riverside Township on a speedboat. The speed of water is estimated at 6.0 meter per second on the particle. So, the question is, if the student has to move the boat at a constant speed of 8.0 meter per second, at what angle should the boat be pointed relating to the north if he is to land exactly opposite the straight point? So, what should you do if they have asked you that question? I like this question because now the examiner is in Copper Belt. They say something about in Kitwe. So here the examiner about Tandera. So they are in Copper Belt. So they are in Kitwe. Now this is question is in form of relative velocity. Now collect this data. So first thing you need to know on data, they say Kafue flow from the north to south. So from north to south. So the river is flowing from where? So the compass is this, NES. This is the compass. Now they say Kafue River is flows from north to going what? To south. So Kafue is going this side. Now they ask us what? North to south. And the question continues, the velocity of the river. So the velocity of the velocity of the speed of water is estimated at 6. So the speed here is estimated at what? 6. Yes. And also the student has to move at a constant speed. So a student has to move at a constant speed. For now, you need to draw a free body diagram, or you need to draw a diagram which can show this, and it will help you using that question. So let's draw. So I'll draw. This is my river, ka, ka, and they say the river is flowing where? Ka. The river they said it's flowing, so the river is going this side. Ka. So north going what? To south. That's what they say. Now here it is the boundary. I'll say this is a boundary. Ka, ka. Now if this is a student is on here, this is a student. I say is here. So this student has the boat, here. He wants to cross this river to other side here, to come to other side, or to come at this town. Now, what should we do? I explained this that when you are crossing the river on relative velocity. So if you haven't watched our first video on relative velocity, please try to watch the first videos on relative velocity. So I said you need to point exactly when you need to point exactly where what the current is. So the boat, instead the student to cross this river successfully. So he needs to point his boat this direction. Now this direction they say it is what? It is, they say the speed of the boat is, they told us in the question it is what? I say it is 8. They say it is 80 meter per second. That's what they say. Now the velocity of the river. So if the person point here, he will not reach here because the boat current will, they will try all the best. Even the boat current will push that person to reach this. So this person will, the boat current will push him to this until he reaches here. So here the key concept which you need to know, it is the current. That is the key concept. How current pushes. So the river current, they say it is what, 6. So 6 point meter per second. Now they want you to calculate what? Here the question, they want you to calculate the theta here. That is the question which they want us. So they want you to calculate that this theta, the angle which a person should go this side to point in at the current, so the boat can reach the destination. Now when you look at this, you are seeing something here. Let's visualize. This is a triangle. This is a triangle, like you know this. This is a triangle, right? And then this is a theta. So you are making what? A triangle. So if you are making a triangle, you say the velocity of the boat, they say it is 8 here. Then here the velocity of the river going inside, it is 6. Now they tell you what they want you to find, what the theta. And the theta, I explained that the formula to find the theta is tan inverse, which is y over x. Now, do we know the y? We know the y, it is 6. Do we know for x? We don't know the x. So your goal here is just to calculate the x. So using what we call Pythagorean theorem, we can able to find here. So our x is equal to, according to Pythagorean theorem, it is 8 squared minus 6 squared, then the square root. So here you get it to be the root of 28. So x will be the root of 28 is 5.3 meter per second. So that is our x, 5.3 5.3 meter per second. I can say 5.3 meter per second because we are dealing with him velocity. So here, if they didn't ask us, if they ask us find the velocity of the boat relative to the town here. So the relative to the town, we can say it's 5.3. So the boat relative is 5.3 here, which you have found here. Now after you have found 5.3, we can calculate now the theta which they have asked us. So the theta is so tan inverse. So tan inverse, y, we know why it is 6 over 5.3 meter per second. So when you calculate, what are we going to find for the theta? So the theta, you'll find it is 48.52. So 52 degrees. So that is the theta. Yes. So theta is equal to 48.52. So the question is simple and easy. So those are free marks. Relative velocity is the free mark in the exam.